name is Harm Cervantes.
My name is Reagan Fornstrom.
My name is Thelma Gonzalez.
My name is Swathi Ramkumar.
My name is Jack Warlock.
And this is Project 22019, Thrombus Growth and Adhesion to Tube Wall. We are sponsored by Becton Dickinson and Company, or BD. So the introduction to this project and our project goals, the team is working with the disease of thrombosis. So thrombosis occurs when a blood clot blocks a blood vessel in a biological system. The causes can be obesity, disease to injury or legs, longer periods of immobility, and certain medications. And there are two types that we work with, both venous thrombosis and arterial thrombosis. Risk factors include smoking, diabetes, hypertension, high cholesterol, a family history of thrombosis, lack of activity or movement, and age. There are two current treatment options available, which include medication and surgical intervention. For medication, we use anticoagulants, which thin the blood. Or for surgical intervention, we place catheters and stents within vessel walls to widen them in order to loosen the clot. All of these treatment options are advised and based on age, overall health, medical history, and tolerance for therapeutics. However, both treatment options are not time sensitive. Thus, BD has recognized this gap in the industry and tasked their team with creating a model or out-of-body model where a thrombus is attached to a tube wall, so medical devices and industry standard catheters can be tested ethically.
Shown here are the part drawings and assemblies for our project. On the top left is the 3mm inner diameter tubing. On the top right is the 7mm inner diameter tubing, and on the bottom is the 10mm diameter tubing. Each tubing was cut to 10 centimeters, which is shown on each drawing, as well as we initially had stoppers on the ends of the tube, but we changed them parafilm instead, which was colored black, so you can actually see the parafilm on the end. As well, here are the requirements. We split up requirements into 5 different sections: performance, environmental, safety, interface, and design features. But the section of the requirements I want to focus on is 4.1, the performance requirements, which were given to us specifically by our sir, that the clot thrombus needs to adhere to the tube wall with a length of 10 centimeters, adapting to diameters from 3mm to 10mm, and have some mixed morphology present in the blood itself.
Our initial design was focused on creating a thrombosis with pig blood mixed with sodium citrate as the anticoagulant. We mixed the calcium chloride as a neutralizing solution to inhibit sodium citrate so that the pig blood would coagulate. Also, we used plastic tubing as a housing for the thrombosis. Our second design, we changed the ratio of the calcium chloride solution to the blood, as well as performed surface modifications to the rubber tubing to increase greater adherence to the tube. Our third design, we changed the molarity of the calcium chloride solution, as well as the ratios of the solution to the blood. Along with that, we finalized the treatment of the rubber tubing. The final design, we did coating the inner tubing with collagen. Along that, we have also just finalized on surface modifications.
As Jairo mentioned, there was various treatments to the tubing with a raised ratio of blood to calcium chloride as the final design. So this final design had high adhesion at both 7mm and 10mm, although the 3mm tubing had some problems, so an alternate method is needed. As a final acceptance review of our project, we tested with an industry standard catheter to demonstrate that the thrombus had coagulated inside the tube. As you can see, this catheter is able to remove the Thrombus, but it has remained within the tube. As another check for our verification progress, we perform the verification procedures and use test data sheets to track our progress. Shown here are the adhesion demonstration data sheets and the clear tubing inspection data sheets, as well as the length inspection data sheet, which were used to verify that we met the requirements of the project. Additionally, throughout the project, we identified various risks in order to mitigate them. We had many common risks that repeated due to the continuous prototyping, such as the extensive prototype iterations, time constraint due to blood delivery, or other risks. And then we also had a high extreme risk of the addition of the COVID impact on personnel and supply chain. We mitigated these risks through planning early and prototyping often, as well as being flexible with scheduling within the lab.
This slide goes over our budget. On the left, we have our purchases, which do not include the tools and items that were generously given to us by our lab. This includes tubing, blood, and other items we use for our experiments. And on the left, we have the overall budget summary. With the poster, we have spent a total of $1,359.42, leaving a reserve of $2,640.58. Meeting our requirements with the project being inexpensive.
This is the poster that the team has designed in order to present for Design Day. It has an overall view of our methodology, our goals, the results of our project, as well as any conclusion and future directions we believe the project should take. Overall, the team has been able to meet all of the goals that were outlined for us. And if there are any questions regarding our project, we would be happy to answer them. Thank you so much.